Thanks everyone for coming. Welcome to this, our first webinar for a long time actually for the UK PUG. It's great to have you all with us. Don't think Mike needs a huge amount of introduction, but Mike Fechner, thanks for coming to talk about ABL legacy code analysis and migration, Proparse, that sort of thing. If you've got any questions, then please pop them in the chat and Mike will either answer them as we go along or at the end, but that's the easiest way to do it. But without any further messing around, I'll hand straight over to Mike. And yeah, thanks, Mike.
Well, thank you, James, and welcome to everybody this afternoon meeting. Yeah, before I dive into the topic and well, do a short intro of myself. Legacy code analysis and migration with Proparse, talk of the day. Proparse is an open source tool around in the ABL community for quite a long time. I wouldn't be able to tell you when it was first released, probably more than 20 years ago. And we've been using it intensively in the last 10 years for analyzing code and, yeah, well, helping with migration of progress applications. Before I go into that, give me a chance to briefly introduce myself and company I'm working for, Consultingwerk. So we support open edge developers as an independent IT consulting organization. Our expertise is focused around open edge and related technologies, so technology that makes sense to be used together with open edge by open edge developers, like maybe .NET framework, web technology like Angular, Docker, etc. Our main office is in Cologne in Germany, but we do have subsidiaries in the UK. James is one of my colleagues there. We do have colleagues working from home offices in the Netherlands, and we do have an office in Romania. We're working with customers almost around the globe, customers in Europe, North America, Australia, Southern Africa. And yeah, what we support our customers with are consulting services, also development services. We also do bespoke development every now and then. And we are the vendor of developer tools. One of the developer tools is a smart component, and I'll introduce that briefly in a second. There are a couple of areas that we have specialized in over the last couple of years. And I think some of these areas we've made ourselves a name of being the go-to guys for those topics like OpenEdge GUI for .NET, Angular, object orientation in the ABL, software architecture in general, and application integration. And well, we use all this experience in supporting our customers, mostly during modernization of OpenEdge applications. I'm supporting our customers there then in the role of an architect for modernization related questions. Yeah, for the development of our development tools, the smart component library and the WinKit, I'm also in the role of the product manager, architect, and well, very often also developer on those. I've specialized myself on object-oriented design, of course, especially around OpenEdge. But also in other environments, software architecture in general, desktop user interfaces. I do have some I have good understanding of web technologies. I would not say I'm a web developer, but I would say I have enough knowledge about web technologies to ask the dangerous questions. I'm using Progress on our OpenEdge since version 5. So that was 31 years ago. And while I try to be quite active in the OpenEdge community, and also speaking at conferences, which, well, in the last 12 months has been a little bit challenging, but well, there are these online occasions like this year today. Yeah, with the smart component library, we believe we help our customers to protect investments they've made in the past in their OpenEdge-based applications. Framework has been designed to support the modernization of existing OpenEdge applications, but it also at the same time provides a very robust foundation for building new applications. Applications that could be deployed in the cloud or on premise, following the principles of the OpenEdge reference architecture or the common component specification. We believe that we've achieved the design for the framework which is proof for future technologies and implementation of all sorts of business requirements that may be coming at our customers. One of the things that the framework does provide, among many others, is user interface flexibility. We provide a Windows desktop user interface based on .NET UI technology using the OpenH GUI for .NET. We provide an Angular web UI based on Kendo UI components. We provide UI for mobile applications based on NativeScript. NativeScript is an open source UI technology that was launched by Telerik or Progress Software. Our framework provides open standard-based interfaces such as RESTful, which makes it very easy for every developer to implement other UIs if they prefer. And we do have partners that provide their own UI technology on top of the smart component library, like the Axioma Spot framework, for instance. Yeah, the agenda for today, I'm going to talk briefly about strategies for modernizing open edge applications and also then why harvesting existing code might be important. Then I'll talk generally about source code analysis, and then I'll introduce Proparse. What is it? How can it be used? And then based on 3 use cases, I'm going to demonstrate how we are using Proparse to help with speeding up various aspects of harvesting structures from existing applications. And then I'll close with some conclusions. So when we get asked by a new customer or maybe an existing customer about a new modernization project, whether we could support them, it's always the question, well, what are the goals? What is the partner trying to achieve? There may always be many goals. There may be conflicting goals. There might be the need to prioritize goals in comparison to others. But generally, these goals can be separated into 2 categories: the functional or the non-functional requirements. So what is the application doing, or how does the application solve the requirements? So with customers that refer to modernization project with something like, oh, we need to add a new module. Maybe customers have been asking for many years for a replacement of a planning module. That could also be called a modernization. There could be changes in business or legal requirements, new laws. I don't know whether in the UK something is coming there because of the Brexit. We typically deal more with the non-functional requirements. People coming to us and say, hey, we need a new and more modern user interface. We need to improve our users' experience, which could be solved using modern desktop, a web UI, or a mobile UI. Customers sometimes come to us and say, hey, we explicitly need a new architecture. Something that also falls into the more non-functional requirements is maintainability of code. We have some customers that started modernization projects, huge modernization projects, because they realized that the code base has gotten so complex that they cannot make functional changes anymore, and therefore the non-functional requirement arose of, hey, we need more maintainable code. Performance when deploying over WAN may be a concern, and very often we hear customers, well, we could deploy over a wide area network, but that would require us the use of Citrix, and probably everybody knows Citrix is not a very cheap tool. Citrix is quite expensive, so maybe Citrix licenses justify a modernization somewhere. So, and how do we go there? Well, there are 2 approaches, and that depends also then on the goals. Is, well, do we immediately make the decision to modernize the whole application at once, or do we start with a different approach? So when we go with a whole application at once, that could be from a TTY or an ABL GUI application to a more modern desktop or web or mobile UI. One of the challenges there is these projects very often take years. we're convinced that with our framework we can speed up the time, but still it's a huge effort. If you say, hey, we want to go straight from where we are to a new, maybe web-based UI, that means very early in the process, you may have to make a decision about the final UI technology. And those people that have experience with web technology know that the technology that changes so frequently that probably if you're thinking even just about a 3 years modernization for a whole ERP system, the decision about the UI technology that you make in the beginning of the project will be so outdated when you're done with the project. So maybe that's not the best approach. So maybe then it's better to go via an intermediate, which I'll introduce on the next slide. Some customers prefer, well, we first want to win some experience with the new technology, and therefore we do a pilot implementation, a pilot project. So that might be a mobile client for specific pieces of the application that provides also very quick value to customers, looks very nice on data sheets of application. Oh, we have these 3 mobile applications for different user personas. We have customers that come to us and say, hey, we need to introduce RESTful interfaces. Can you help us doing that? Because REST is the standard today for application integration. Also, that can be a first project that helps getting used to then also things like new architecture, app server, how to provide those interfaces securely, how to deal with authentication, authorization, etc. All this helps together the team of developers experience with new technology at a reduced risk, because those are typically smaller projects. And if for whatever reasons they fail, well, the risk is much lower. So an example for migration strategies that we are proposing to customers, depending on whether it is the right strategy for their needs, but very often this fits very well. So let's assume we're going from an existing open edge application. Might be based on Progress Dynamics, could be all homegrown, doesn't really make a big difference. One idea might be to go straight into the web application, if the web application is the target UI. But then we have all these disadvantages. Then we have the big risks, and the implementation decisions made at the beginning of the project might be outdated when we're done. So maybe it's a wise intermediate solution to say, hey, if we look at from left to right, what are the components on the right where we can go to quicker without less risk of making false decisions? And if we know one thing about OpenEdge, it's pretty stable and it doesn't change that often for good or bad reasons. So maybe a good approach is to say, hey, we first introduce an app server backend. Nowadays, that would be the PaaS app server with a framework that can serve both the web application later, but now also a more modern desktop. The big advantage here is that we can have successive releases. So we can actually integrate into the existing GUI application, modernized screen by screen by screen, and have very fast releases that way. Integrating a desktop and a web application in that same way is so much harder. I mean, James just mentioned the webinar that we're probably doing in 4 weeks about using Chromium embedded as a web browser embedded in a GUI application. That helps with this dilemma a little bit, but still, this is an approach that is allowing you to deliver more quicker. And the backend that is being created here, so existing business logic being harvested in the old application, converted into something then on the PaaS OE, ideally the same backend that now serves the modern desktop UI will later be able to serve the modern web application, so that then the time required to change from the modern desktop to the web application will be significantly lower. So that brings us to, well, how do we speed up the migration? Well, source code analysis is then an important thing. I don't know a single software vendor that could say they have somewhere on a bookshelf a complete documentation in prosa text about what the application is supposed to be doing. Usually the only complete documentation of what an application does is the source code of the application. If there's somebody who has this complete documentation, congratulations, but I've never met someone like that. So the ability to analyze the existing source code is very, very important if you're aiming for partial migration or any form of iteration of the application, what it does, and maybe redundancy, etc. And with analysis of application, we're distinct. We're having two distinct techniques. One is the static code analysis, where you just look at the source code. There's no need to execute the application. And the other one is runtime analysis, where during the application execution, you look into that. One example for runtime analysis would be if I later introduce you how we use Proparse to understand ABL UI layouts. Very often I get asked, why don't you do that by going through the widget tree? Well, the widget tree requires me to do that at runtime. And that means I need to have an environment where my tooling and the application to be inspected can run in a single session. And that may not be so easy to achieve. So with source code, it's much easier. OpenEdge provides some out-of-the-box features for static code analysis, typically by the compiler. So there's the compiler cross-reference that are features of the compile statement that allow you to return either the cross-reference, so a report about which include files, run statements were in the source code, access to buffers and variables, strings found in the source code, which has been used for translation in the Tranman as well, or the listing. That's something that tells you decisions that the compiler has made about scoping of buffers, variables, and transactions, etc., frame scoping, or the preprocess or the debug listing, which includes all the include files into the source code and actually shows you the full source code as processed by the compiler, etc. All those are features for static code analysis where the compiler helps us. For runtime analysis, there's also quite a lot in the OpenEdge box. There's the profiler. The main purpose of the profiler was to help investigating performance problems. It tells us which routines have been executed and their timing, which statements have been executed and their timing. And if you're using the Sonar Source plugin for OpenEdge, then based on the profiler features, the Sonar Source plugin can tell you which exact lines of code has been executed by any of your unit tests. And that makes it easy to find out which lines have not been executed by unit tests, and therefore where do you need to add additional unit tests. A lot can be investigated using the features around the log manager system handle that could actually tell you which queries are really being executed. It can tell you something about parameters and their values, and also something about time. And then there's the dynamic inspection of widgets or queries that I mentioned earlier, where the ABL provides a lot of functionality. And sometimes it's important to look at those too, but usually we've made better experience with static code analysis. And that's where Proparse comes into play. Proparse allows us to look at source code in a very detailed and structured way. Proparse is a tool to build a so-called abstract syntax tree for the ABL. Proparse does it based on very detailed knowledge of the grammar and the semantic of the language. It knows all the valid keywords, valid combinations, and their meanings. So for instance, a run statement together with the persistent option has a slightly different meaning than a run statement without the persistent option. It understands language concepts like the scopes as well. It can tell us things like whether a variable that we're accessing is valid just within an internal procedure or in the whole.p file. Proparse is based on a re-implementation of the ABL preprocessor, so that if your code is based on that, Proparse can deal with that too. Proparse can ideally interpret all ABL code that can be compiled. challenge with that sometimes is there's ABL code that compiles that is not documented to be compiled. So sometimes there's surprises, and then Proparse needs to be fixed, extended for that. But usually I would say it can interpret all the ABL code that can be compiled. One example, just a couple of days ago, a customer of us called us, or emailed us, said, hey, we have a problem with Proparse, and the define buffer keyword has a very rarely used option of define buffer B customer for temp table customer. I've never seen that logic, to be honest, but they use it, and Proparse wasn't aware of this. So we have to extend Proparse to understand that source code. But Proparse is so widely used, these occasions are typically very rare where you still run into problems with Proparse not understanding your source code. Proparse requires all the same information as the compiler. So Proparse needs access to the database schema. Proparse needs access to the Proparse. So Proparse needs access to the Proparse, and all the reference source code, especially the include files. One difference to the compiler can compile encrypted source code. Proparse is not able to decrypt encrypted source code, so it needs unencrypted source code. So why do we need an AST? Well, the alternative would be just reading the source code into an ABL runtime or whatever tooling and dealing with this as just plain text. And parsing that text is quite complicated. And just by looking over the code, we would also then have to be re-evaluating these concepts like the scopes of variables or parameters, etc. ourselves. So in Proparse, this is all provided as part of the Proparse implementation. So I said it before, ABL can be quite flexible. We could have a whole data entry screen in a single line of code. It would not be a single statement, but a single line of code, or in thousands of lines of code. There are many keywords with that are quite relevant, and sometimes, depending on where they're used, have a different meaning, like the input statement. The input statement could be a reference to the screen value of a database field, as the input keyword, or the same input keyword could be the useless decoration on a parameter to a function or a method or so. So sometimes the order of keywords has a meaning. Casing of keywords has no meaning. Some keywords may be used as identifiers, and that's quite bad. If you're searching for certain text and suddenly you find variable names instead of the keywords. Dealing with quotes and must quotes and double, all that is quite ugly. So it's quite good that this has been implemented once in Proparse and does not need to be re-implemented. So if we look at this program here and that program and that, they all do the same. Just different flavors, different programmers, maybe different programmers with different days. And if you would have to pass those, that would quite be nasty. Proparse looks at it in a tree. The Proparse abstract syntax tree is, like the name says, abstract. There's no visualization for it. So one of the first things that we did when we started working with Proparse, we have built a tool to visually represent the tree. And the most logical control for that was a tree view control. So what we see on the left-hand side is the syntax tree represented in the tree view of the program on the right-hand side in the editor. And there you see, well, if you just go through the first column in the tree, you can actually almost read the source code. So you see a defined variable. Okay, then there's an ID, and then in the third column, I see the name of the variable as integer initial 21 in the third column again. So it looks pretty much straightforward like the structure. But if you then look at the message statement, you see that the multiplication of I multiplied by 2 is actually coming from the inside to the outside. So multiply as the operator is the top node to then the two values. One is the reference to the variable I, and the other one is the number 2. So this is how Proparse would look at this source code. And this form might be a bit confusing to begin with, but it's definitely, if you're using this frequently, much easier than using the source code on the right-hand side. There are different types of nodes. Proparse, I have said on the next slide, is implemented in Java. So the different types of nodes are represented by different classes. The regular node, the most simple node, is called the JP node. I would guess that stands for Java Parser node. And then there are special nodes, and one of the more common special nodes is the field reference. That's a reference to a variable, and it's an extended class. So it inherits from the JP node, but it provides additional information like, well, what is the scope this variable is valid in, and what are the other pieces in the source code where exactly that same variable is referenced to, which makes it quite straightforward to make decisions about, okay, well, I may need to move parts of the source code into an external procedure so that it can move from the UI to the app server, and you know exactly what other bits of code need to go with it. Proparse has been originally developed by John Green, a Canadian consultant. His company name is Juanju. The original source code repository that he was working on is still available on the Juanju website. Then there's the OE Hive. OE Hive is a collection of a large number of open source projects around OpenEdge. Their version of Proparse is maintained. The Java class documentation with all the details about the classes of Proparse is still hosted on the Juanju website. It was released under the Eclipse public license. That's a license that allows it to include it in commercial products without the commercial product having to become open source. It builds the syntax tree for a single compile unit. Even though it is similar in how it looks at source code like the compiler, it will never replace the compiler. You still need the compiler to make executable code. But it has similar requirements. And John Green didn't start developing Proparse out of nothing. He based it on Antler. Antler is a tool for writing language parsers. I'll have some more details on that in the next slide. So today there are a couple of public source code repositories. There's the one from OE Hive, which, well, I think contains most of the OpenEdge 11 syntax. It's not that active maintained compared to ours. We maintain Proparse because we need it for our tooling, and we make all the code changes available on this GitHub repository. The Sonar Source plugin for OpenEdge makes heavy use of Proparse too. So there's the Riverside version of it. The Riverside version has been migrated to a newer version of Antler already, but what they are not providing is a version of Proparse that can be used in ABL code. So that might be a variant if you're developing your tooling in Java, then you could use that version of Proparse. If you're developing your tooling in OpenEdge, I would recommend using ours. Proparse has been relatively dormant in the first decade of the century, but since 10 years or so, it's actively maintained. It supports all syntax that I'm aware of OpenEdge 11.3. Well, there is this defined buffer for temp table that I wasn't made aware of a couple of days ago that will be fixed soon. So that includes the new var statement that has been added in 12.3, I believe, and the equal plus operators and equal minus operators, etc. That's really a foundation that should allow you to pass everything. Antler, well, another tool for language recognition is what the acronym stands for. That's a toolkit for building source code parsers. So Proparse is not the only parser based on this. Proparse is based on Antler 2.7. That's quite an old version. There are much more modern versions of Antler that provide lots of more tooling support that would make it easier to generate parsers also in other languages. But the migration of Proparse to Antler 4 would take quite a huge effort, and we do not have plans to make that in the near future. It's not really blocking us. We can do with Proparse what we want to do. Somebody else wants to do that, you're welcome to do it. Maybe we could do it together. I'm not saying it would not be worth it, but yeah, we don't have plans to do that. Proparse needs to learn the grammar of the ABL. So what we see here is an excerpt of the grammar of the message statement. You see there, well, there's the message, that's a token name. He's waiting for that. If we look here in the message options, you see another token, yes, no, cancel. So before we come to the grammar, the keywords are defined, and there in the Proparse declarations, it's defined that this yes, no, cancel actually stands for yes hyphen no hyphen cancel as the ABL keyword, but as the hyphen cannot be used as part of an identifier in Java, these keywords all are without the hyphen. As part of this declaration of the keywords is also defined which keywords can be abbreviated. So the minimum abbreviation of the defined statement, for instance, is DEF. And that's helping Proparse to understand the code. And if you look at the message statement again, the things in parentheses are references to other grammar, kind of like include files. So the message options is a piece of grammar that's included there. The star says that it can be repeated, and the question mark says it's optional. So a message can have many message items and can have different of these message options. And the message item is either a skip phrase or an ABL expression. And this is how the grammar for Proparse is constructed. You'll find that in the GitHub repositories in .g files. And yeah, well, might be quite interesting to look into. So I said Proparse is implemented in Java. So how can we use that in the ABL? And funny thing is there, .NET comes to the rescue. The ABL supports since version 10.2a, so I think that's now 14 years, using .NET classes, as if they would be ABL classes, no limitation. Well, that doesn't help us with Java classes. As a spin-off of the Mono project was started to build an open source implementation according to the .NET specs way ago. A spin-off from that project was the implementation of a Java virtual machine embedded into the .NET framework. So this IKVM, I and K have just been chosen for the name because that are the letters surrounding the J in the alphabet. Basically takes care of all the binding of Java classes through .NET into the ABL. It's still an active open source project. It was also dormant for a while, but since I think 2 years or so, it's again actively maintained. Yeah, that makes it possible to use Proparse in the ABL. And for those who have not seen that, I'm going to show you this sample program. It's available on the GitHub page. The link is in the slides there. So it's an ABL program. It's a .p file that parses a simple piece of source code. And what it does, it defines a couple of, or it declares a couple of .NET namespaces or Java packages that should be used here in the source code using the using statement. And from there on, I can define variables as these Java types through .NET. One of the very important types here is the PU, the parse unit. So that is basically the root structure representing an ABL source code that has been parsed. Since it's all Java code, the way it's opening the source code, so this program is actually parsing itself. No, it's parsing another one. It is through a Java IO file object. It may look funny in ABL source code, but it works very stable. And that is being passed to the constructor of the parse unit, and then we invoke the parser using this parser 01. And then going through the source code, as we've seen on the graphical tree view control that I had on the slides earlier, is something which is always recursive. The .p file represents a block. Internal procedures represent a block within that block. A loop within the internal procedure is a block within the procedure log, etc. Processing Proparse or using Proparse to process the source code is always something that is recursive, starting from the top node of the program. This procedure process AST is receiving a block here, or a node representing the procedure, the whole procedure at start, and then iterates from the first child of that node. So it's a little bit like going through the widget tree. They also have first child and next sibling. And then recursively calls itself, passing the current child as the parent to the next iteration. And we increase the nesting so that this procedure actually gives a tree-like output. And so then of the actual nodes, there are a couple of properties which are relevant. It is the type of the node, the actual test. So the type of the node here for a reference to a variable would be, for instance, an ID, or the name, and then the get text would be the name of the variable. And toString is the actual source code behind that node. And with this recursive loop, you can parse all programs. And well, then you just need to do something with it. So what do we use this for? Well, we use this for refactoring or understanding all kind of ABL source code. We can migrate frames, or we can migrate from various frameworks or from no framework at all to new code, because it's based on the language. The language is also common denominator. There's no limitation when we can use this. There are a couple of tools using this. I've mentioned the SonarQube plugin for OpenEdge. That's actually formerly called Cabal, or officially called Cabal. And then a number of utilities in our tool set. We have traditionally been using Proparse.net, but last year we have implemented another wrapper around Proparse. We have embedded Proparse into a Tomcat web application with a RESTful interface, which allows us to use Proparse also to analyze source code when there's no Windows environment. The .NET integration only works on Windows PCs, but we also want to be able to use parts of this tooling on a Unix-based app server, for instance. So what can we do with this? We can migrate ABL UI layout. And when the requirements say, hey, we want to have the same application functionality or a lot of the existing application functionality, but just brought to a new UI, then maybe the UI layout also becomes some relevant. The UI layout may be a starting point, but well, it should also be clear that this may need to be edited later, because something that has been designed for an 800 by 600 screen for a desktop doesn't make a lot of sense as a exact adoption when you're going to a web browser running on a large modern desktop PC and when you would need responsive UI. So that's a starting point, but later editing should always be possible. ABL UI layout is typically based around things like the form statement or defined frame statements, defined window, and all these others. The thing that makes this a little bit complicated is, well, if you just look at the source code, sometimes we need to combine multiple defined frame statements into one. That's a technique that people could be using when the statement size was too big. You could just define your frame in 2 statements or 3 or 4. Some properties of the fields are not defined on the widgets themselves. They are inherited either from the data dictionary or are just defaults in the ABL. And well, you need to know them, because when you migrate that to another UI technology, it might be important to keep those values that in the ABL don't appear in the source code. Yeah, well, the positioning might be a bit funky. It might be based on explicit position in the source code or based on just a skip phrase. So here's some very simple ABL frames. And so using Proparse, you could parse the source code and then actually generate this example as a GUI for .NET layout. So that is within the Proparse Developer Studio here. And how do we do this? Well, we start with the ABL source code. Could be .p or .w file built in the procedure editor or app builder or anything else. Doesn't matter how many frames there are, ADM, ADM2, whatever. And well, we first pass this program with Proparse. And Proparse then tells us, well, which frames we find. We can then use an ABL class that we've written, the frame parser, to actually iterate the abstract syntax tree recursively. Yeah, look for what fields do we find in the frame and what are all their properties. And then we add the known ABL defaults or the data dictionary properties to that. Known ABL defaults, for instance, something as trivial as like a character variable, if you don't define a format, will always have the x8 as a format and things like that. This process is customizable through events or callbacks, but sometimes you want to make certain changes there. And I'll have samples for that soon. There can be temp tables. The result of that is a temp table. We always try to make the tooling quite easy to use for ABL developers, and the temp table is just a very easy to use structure there. And then out of that structure, we generate whatever target UI. That could be GUI for .NET, that could be straight Angular web UI, it could be an abstract UI definition, for instance, JSON, that's what we use, or we could generate objects in a UI repository. And during that process, we can also then, when we generate the new code decouple the database access, for instance. And the new codes that we generate could be bound to fields from temp tables from a business entity. We could even generate a business entity that's capable of serving a screen that way. Well, of course, certain knowledge about what the target UI is improves the results. We know that when we have a classic abl.w files where you have a browser and update fields in one frame, we typically ignore the browse widget, because in most modern UI layouts, the browse widget would be a component of its own, and the update fields would be in a viewer or whatever you call it, a viewer, form, or so on. We can even pass the trigger code and can migrate it in partly. And we can customize this through callbacks and events. So that would allow us, for instance, to ignore rectangles that only surround a single widget. I mean, there are many ABL GUIs where you get rectangle overflow quickly. So let's quickly look at how this works. So, and most of our migration tools are actually very boring and headless, don't have a UI, but we have a couple of these that specifically for presentation purposes, we've provided with a user interface. So, and this is the one that we have to migrate frame-based UIs. So now I'm opening just a very simple .w file, and the first thing that Proparse does, it looks for which are the frames. And in this one, it's just one, and then we see, and that's the result of this temp table, all the fields that we found there, with all the properties and database fields and well, the properties partly coming from the source code, partly coming from the data dictionary. We see the browse widget has already been deselected, and in the same way I could be deselecting the rectangle or not, and a callback could have been decided to also skip additional stuff. I see there are two questions why we're not parsing it straight into XML. Well, the temp tables that we're getting, we could be outputting them into XML. That would be quite easy. That answers Pete's question. And there's another question: how do we handle external controls like CodeJock or Windows OCXs? Well, OCXs are a problem because the properties in the binary property container and the WRX file are not visible to us here. So that would be a limitation. Good. So what I can do from here, there are a couple of options. I can just click on a button and let's go that way. I generate now a GUI for .NET screen out of that. And the screen has been generated right now. And I'm going to open it in the procedure editor first. We see it defines lots of variables of various .NET controls. So we have a process here that turns it into GUI for .NET in a form that can be opened by the ABL Visual Designer. That just requires to use the correct set of templates and follow certain rules. Yeah, that was one of the rules that are violated is .NET doesn't like hyphens in the name. So that was a demo effect. So I'm going to generate it without a hyphen. So same file basically, but without the hyphen. So I'm going to open that in the Visual Designer. So, but we see the same layout. Well, that was easy. When I click on the fields and go into the property sheet, the fields are data bound to fields in a binding source. So we've translated the data binding, which the old code was there, just by using the database fields directly. That has been translated into ABL code, into the .NET variant of data binding. So it was triggers. So we found the value change trigger on one of the fields, for instance, and the trigger code has been commented out. That's something which with UI triggers is always a good idea. It typically always requires human decision what code is relevant and what not. So then we have the code blocks that was in the old file. That's straightforward. But on top of that, we've looked into the code, which widgets are there. And the UI consists of .NET components, and the source code references ABL components. So what we have is we have defined facades. That's an OO technique, which lets one system look like another system. So that are basically adapters that translates properties like the screen value or sensitive, which is common in the ABL, to the properties of the .NET widgets. And with that, this source code here is usable. And just to show you how little changes that are. We're not doing it automatically, I'm doing it manually. So now this trigger block, it doesn't do a lot, but that works perfectly fine against the .NET UI components. And we can do way more complicated things, but so much just for the demo here. One of the things which then often also comes in place, detection of UI patterns. A very common UI pattern are lookups or zoom fields, call them what you want. So typically it's a combination of, well, you have a key field, a detail field, a lookup button, an event handler for leave, or a shortcut key like F3 or F4 to open a search dialog, etc. And very often in classic applications that are not based on a framework, that is repeated in hundreds of .w files on many fields. So that's a UI pattern, and it just makes sense to teach migration routines to detect those. And what do we use for that? Well, we use a combination of the logic of the relative orientation of widgets on the screen, like we expect a button straight next to a field and maybe a description field after that. But the description field is optional. Then we expect on the field left of the button an on leave of blah, blah, blah trigger. And if in this trigger we find a find statement referencing the screen value of the field, then we're pretty sure that looks so much like a lookup that this becomes a very, very hot prospect for that. And that's something that we can do as well. And so the tool that I've showed you earlier supports plugins for handling certain of the events or callbacks with specific logic tailored to a specific application. So that allows us to customize that. And the result of that is that when I open another variant of that view, and I can show that in the ABL first. This one. So that's the app builder embedded. So we have here one prospect for lookup and there a prospect for lookup. And I open this one now in the tool. Then we see that customer.country already has an alternative control name that's a reference to a lookup component that we've defined in our framework repository database, that this country field should be replaced by the country lookup, and this one by the sales rep lookup. And now I'm going to generate something different from this. I'm going to generate a viewer layout in the repository. And there I have no problem with hyphens. And I can open that then in our own designer. Let's start that tool. This one. And if I look at the design here, we see it looks pretty much like the same, but the country field and the sales rep field have now been turned into lookup. And what that means is the lookup button are really tightly coupled to the field and not to just randomly placed together components. So that's then what really provides value is understanding of UI patterns like that. And there can be more UI patterns like that. It could be a date from, date to field. It could be if you have a date field and you have the up-down buttons that we say, oh, these buttons, they're no longer needed because the .NET components or the Angular components could do that by themselves. And then this is part of the code that looks for these leaf triggers and sees what they do. So we're looking here for a find statement with then the record name, and then we look for the where statement. So this Proparse helper is a class that we've written that provides a lot of search functionality around nodes. Yeah, based on that, we then implement the logic that interprets the existing source code and makes certain decisions. We have similar tooling for other UI widgets like browsers or the entire window. We have experimented with generating not only other ABL code, but also kind of like skeletons in form of other source code. So the ifs and else's, etc. That's quite easy to generate JavaScript or TypeScript code out of that too. Of course, when the code uses other ABL statements, then it gets more complicated. But again, here it would already be a huge time saver if you just use basic structure like ifs and else's, etc., and loopings, and then paste ABL source code, and then let the TypeScript developer do the translation. So, use case 2, detection of validation code. Validation of user input is a core responsibility of every business application. No business application will let a lot of data into the system which is not validated. And validation code in legacy applications is either implemented straight in the UI or may already be separated. Very often leave or value change triggers or code on the save button. There may be naming patterns for internal procedures or functions like validate custom that would be called then whenever the custom needs to be validated, etc. The ADM2, for instance, has the smart data object that has certain validation patterns. And this code can also easily be found. And even if we don't know where to search for it, typically code that has some form of ifs and else and looks into the screen value, looks into other database tables, and if something's not right, informs the user using message statements or maybe a message procedure that you may have or whatsoever, moves focus back into another, all that code that smells so much like validation code that it's easy to find. Now I have an example, update editing. The reason why I'm using this update editing example is 2 things. One is, it's a very TTY-like construct. So previously I've been showing most of the things in GUI, but we can pass TTY code in exactly the same way. And the other thing is, you shouldn't leave this webinar with the impression that we only can deal with ADM2 applications. We can actually deal with very, very old stuff. So that's why I've used the update editing as an example here. So update editing is validation executed after every key press. It's a huge block, probably the biggest block that most programs ever had. It's not that common in GUI code, but I've seen that a couple of times in GUI code as well. And well, there are also certain statements that go along with that. And here's an example of an update editing block. So the update statement, if you look closely to that, is not terminated with a period. So the editing colon is a block that is in the update statement. It starts with read key. Then you see these checking in which field I have been. Frame field is where you are. And if the field you have been in is not the same as where you are, this is basically how a leaf is detected. Go pending is if the user presses the save button, etc., etc. So, and if you look at this, well, we see, okay, it checks name, customer name should not be empty. If it's empty, we have a validation message, blah, blah, blah. For sales rep, we try to look up the sales rep in the database. If it's not there, we prompt the user to change the sales rep. If it's there, we display the sales rep name. So kind of like a lookup-like functionality. So I'm going to the tooling that was on the screenshot in the beginning that shows a program in the graphical tree view. And I open the update editing sample. So on the left-hand side, we see the tree view of the program. And some of these procedures are quite big. That's actually the one with the update editing statement. From here, I could open the actual source code, and it jumps to the nodes that I had selected on the left. And I can also do the reverse. I can click on a keyword or before the keyword and let it find in the source code, and so vice versa. So for demo purposes, we have it made visually here in the source code, in the tool. I can search for this update editing statement, and it jumps to this update editing statement down there. And then I can convert this selected node. And when I click on that, it's now searching for business entities, because what we want to achieve conversion of the update editing code into validation code that could be used in a business entity. And I'm selecting a customer business entity. And with that, it has now migrated the validation code found in the update editing code. I can show them next to each other. Where was the update editing? So on the left, we see the old code. On the right, we see the validation code. So we take the same decision, but the message and moving the cursor back into the field, that is here implemented using now an API of the framework, which works then both with GUI4.net and Angular and mobile clients. They all understand what this means. And the same with the sales rep. And if the sales rep is found, the display statement, which updates the screen value, is translated into updating the fields in the temp table and so on and so on. So that's the same logic automatically converted from an update editing statement into code that can be used in a business entity. So if you look at the individual things, the find statement is almost left the same, but the input keyword on the top and the direct database access has been replaced with accessing the temp table that provides access to this database table. We have the message substitutes, the next prompt, and the leaving of the update block, all replaced by this add error string API, and the displaying of the fields from the sales rep code is assigned into the fields of the temp table. So the logic flow remains the same, but the actual code that's executed has been changed, and that is actually an architectural transformation of that code. I could do more. We could also replace the finds with calls into other business entities, but well, the idea here was to keep the sample simple. Good. Let's come to the last use case, detection of call passes. Call passes are also quite important for making certain decisions. When we have rather monolithic code, the same source code contains UI logic and backend logic. So we need to look into the source code and need a foundation for deciding which code do we leave on the front end and which code needs to go to the back end. We do that based on what is happening in routines, whether there's statements that access the database or statements that interact with the UI. So basically, we have made a certain list of keywords which indicate us backend or front end or a mix of them. Then we have built a tool, and this tool is still under heavy development. We'll add more proposals to that. We propose to a developer which pieces of a .p or .w need to be moved to the app server. And one of the extensions that we're currently working on is really actually also stripping that code out and providing then the correct interface to the codes that we move to the app server and on the front end the call to it. One thing that we're using there is the call object in Proparse, and that's one of these things where Proparse is so much more valuable than just looking at the source code. Is the call object provides very detailed information about what we're calling. So if we look at this slide here, I do have this run update customer there in the bottom. And the JP node of the run statement provides a reference to this call object. And the properties, I mean, it's Java, so they're not really properties. They are all functions that are interpreted as properties. Has a lot of properties which tells us what it is. So this run statement is not happening in a handle. This run statement runs an internal procedure update customer, and the external name is the update editing sample.w, so the file itself. So it's barely referencing to itself. Well, I could show you this tool briefly, and then we're coming to the end as well. So if I open a test program, it's not the most complicated program, I can open it here. We see the program, we see the internal procedures and functions of that program, the actual files there, and then here using a set of icons, we see this here is the icon for database for screen access. So if I look into that function, there's a display statement. So that's the screen access. And then other code has the read-only database access, and this has read and write database access. This function calls also the other procedures, and those could be passed to and looked into further down. But let's just stick with this function. So this function itself only has UI code, but we could inherit dependencies, and then we see this function, because the procedures that it calls actually has a dependency to the database too. Depending on how deep in the, or how high up in the stack of a program, probably all programs, all legacy programs depend on the database, but this tool gives us a lot of base for these decisions by deciding, okay, where do we start distinguishing between front-end and back-end code? And well, this tool now can also look at individual blocks. So if you have a big UI trigger, which has a lot of UI stuff, and then a for each that does something in the database, we could also distinguish what's happening in that block and what's happening around that block. So we've had to make some extensions to Proparse and the call object to make this happen. Proparse, for instance, doesn't know about invocations of class-based code. Proparse understands class-based code, but the implementation has never been extended to have a call for class-based constructs. So we've currently done this in the ABL. We are considering to add this functionality into Proparse in the future, but currently that's an ABL implementation. We have added things like support for finding database trigger invocations. They are invisible to the Proparse call object too. So an update statement that fires certain triggers is for us like an invocation of the trigger. Session super procedures haven't been supported. We've added a lot of support for dynamic runs, like run values, where a human developer usually knows what's being likely to be called there, but Proparse will just say, see a variable name. Things like the ADM have a very specific form of overriding. You use this run dispatch with a character argument, and that's actually translated into a internal procedure name, local enable, custom enable, or ADM enable, etc. So we understand those. Yeah, with that, we're quite flexible with finding all of these call passes. There are a couple of planned extensions. We have implemented just very recently the support for treating blocks as individual routines. Based on that, we will then also implement the possibility to strip out individual for eaches or repeat blocks or whatever as app server code out of the UI, and so on. Yeah, with that, I'm coming to my end. Yeah, we have used Proparse now for over a decade for various migration routines. Yeah, it still feels like we're just starting to explore the possibilities. We've built a lot of tools around it. Proparse itself is a great foundation, but yeah, Proparse itself doesn't make you any proposal of what to do with the code, for instance. So that's something that needs to be built around that. We've done that for our tooling. Our tooling is always written with the assumption that there may be a need, or there will be a need, to customize it more or less for a specific coding style of a new customer. But in generally, well, we speed up various aspects of code refactoring that way. But one thing that we've also recognized, it's quite obvious, if you do a one-to-one migration of old code to new code, and your old code has been qualified as hardly maintainable, that doesn't make the new code any better. So with all these automated or semi-automated migrations, it will always require human input, a developer to actually really look over every single line of code. Otherwise, you'll end up with absolutely unmaintainable or old spaghetti or lots of redundant implementations. But I believe this is still speeding up application migration. What I still believe is, even if we would invest another couple of decades into tooling around Proparse, it will never be possible to just click a single button to have a complete 30-year-old ABL ERP system completely migrated. So that's probably never going to happen. What I do hope is that you find this interesting. Well, we ran over time. So if you want to have, well, kind of discussion on what Proparse could do for you, just email us. And yeah, well, we could just have a discussion on what's possible with Proparse. Maybe even you bring some of your existing source code to discussion, even try to parse it using the tools, and see how much of that could be converted. Good. With that, I'm turning to the questions. There was another question from Pete asking what dynamic queries are not supported. No. Well, they will typically not be found as part of the source code. The thing with dynamic queries, what most of the time is more important for us for the decision is which buffers are there, because we might need to know whether those buffers would need to be turned into temp tables for passing them as a parameter to an app server call. And that's something that could be found out if the dynamic query is built against static parameters. The temp table is completely, if the query is completely dynamic, so dynamic buffers against buffer or table names that are passed in as arguments or whatsoever, then that would also be a case where using a callback, we would need to inject human knowledge on, okay, in this case, I'm working with customer. In that case, I'm working with something else. So it depends. Thanks for your time. If there are questions later, you should know how to find us, either via James Palmer or directly to myself. Hope you enjoyed it. Wishing you a nice remaining afternoon and talk to you soon. Bye.
Thanks, Mike.